So on page 5 of our notes, we actually redid all of these problems. So if you go and take a second, pause the video, and copy down the new problems, then you will be ready to get started for us. All right, guys. So guys, today we are going to be talking about another method to solve a quadratic equation.
Teachers, we did have a link showing those kids are in the building and headed to your class.
All right, guys, so we are going to talk about another method of how to solve a quadratic equation. On last class, we showed you guys how to do this with graphing, or with we solved by graphing, or we solved by factoring. Okay, both of those are 100% acceptable, and you could do that in some of these cases. But guys, especially with graphing, it really only works if you have the tools that you need, like the graphing calculator, to make it work, right? So, for example, with this 9x squared minus 100, we could, and it has to be equal to 0 if you want to graph it here. So we'd say 9x squared minus 100. If we graph this, we would see, okay, it's a parabola. It goes way down low and then up. So it does have two solutions. We could find them there, convert those decimals to fractions. Or, guys, I want to show you a pretty cool way of how you can solve this using your square roots, okay? Now, this works the most if you guys do not have, or this works if you do not have a bx term, or if there is a squared binomial. So we're going to look at that. This works in two different ways. If you have no bx term or a squared binomial. So how do you do this? I'm going to give you all the steps, and then we're actually going to practice it. So the first step, guys, is you are going to isolate the x squared term. So you're going to isolate the x squared, or the little squared binomial, all right? It's going to look like that, like x plus something, right, or x minus something, all right? So that is my squared binomial. So the first thing that we want to do is we want to isolate that x squared or the squared binomial, okay? And then the second thing we want to do is we want to take the square root of both sides. All right, guys, we want to take the square root of both sides. And then in the case of a squared binomial, you will have to solve for x if necessary. And you will have to solve for both values. And I'll talk about that in a second, because I don't know how much we have actually talked about this. But I want to teach you, remind you, remember, a positive number always has two, a positive and a negative, square roots. And sorry about that. It always has two, a positive and a negative. We write that little plus or minus square roots. And so as we're thinking about this here today, what I want you guys to remember is, what I want us to understand, I'm going to kind of write this here. If I wrote, you don't have to write this down, this is just for us to think. Guys, what's the square root of 25? 5. Because 5 times 5 gives you 25. But y'all, what I am going to let you know is actually the square root of 25 is positive 5 or negative 5. Because 5 times 5 gives you 25, but negative 5 times negative 5 also gives you 25. You guys feel good about that? So the way we actually write this is, the most common way to do this is you say the square root of 25 is equal to plus or minus 5. All right? So we're going to use this terminology. So when I say plus or minus right here, I really mean positive 5 or negative 5. Does that make sense? That right there means two different solutions. Do y'all feel good about that? Awesome. Okay, so now we are going to actually solve using this. So when do you use the square root method? We've already talked about this a little bit, but we use this when there is no bx term. So if you are in standard form and there's no bx, like ax squared plus bx plus c, if there's no bx term, then you can use the square root method. Or if there is a squared binomial. All right, guys, so these are the two best times that you use a square root method. All right, and so I'm going to kind of show you this. And on this page, all of your square roots are going to be nice, perfect squares. But, guys, it works even if you don't have perfect squares, all right? So I just made them all nice and perfect for you on your notes today. So I'm going to kind of zoom in. So we're going to take a look at this here. So for number 1, the first step that we want to do is we want to isolate our x squared. So if we want to isolate our x squared, I need to add 100 to both sides. Are you all comfortable with that? If we add 100 to both sides, then we will be left with 9x squared is equal to 100. Are y'all cool with that? Then I divide both sides by 9. So is 100 over 9, can that simplify at all? I don't think so. So I'm going to rewrite it as x squared equals 100 over 9. Okay? So this is, and that can't be simplified. So x squared equals 100 over 9. So if we want to simplify this, now we take our second step, and it says take the square root of both sides. Now that my x squared is alone, I'm going to take my square root of both sides, and we are left with x is equal to, well, guys, what's the square root of 100? 10. And what's the square root of 9? 3. But remember, when you take the square root of a positive number, it's plus or minus. So, guys, my solutions are 10/3, positive 10/3, and negative 10/3. Are y'all comfortable with that? Those are my two solutions. And, guys, 10/3 is about 3.33333 repeating. And if you guys take a look back at our graph that we graphed here at the very beginning, 9x squared minus 100, when we graph that, one of my solutions is about, it's just over negative 3 1/3 and 3 1/3. So guys, my solution is positive 10/3 and negative 10/3. Do y'all feel good about that? So this is one way you can do that. Just by looking at the graph and looking at the table, we would not be able to get those values. We would have to use that second trace menu to get those decimal values. All right? Or you can just do it with the square root method with just some good old algebra. All right? Let's try it again with number 3. So we want to isolate our x squared. So what do I need to do here? Ooh, what am I doing? Oh, not number 2. Sorry, I'm gonna do all the odds, and then I'm gonna let y'all do the evens in just a moment. Okay? So if we do number 3 here, we are going to divide by 24. But Abby, you're exactly right. On number 2, we are going to add 14. Okay? So yeah. So here we just divide by 24. Does that simplify at all? What is 54 divided by 24, y'all? They're both divisible by 6. What was that up there in front? 9/4. Yes. So that's 9/4. So then we're going to take our square root of both sides here. And guys, what is the square root of 9? 3. And what is the square root of 4? 2. But it is plus or minus. So my solution is x equals plus or minus 3/2. So positive 1.5 and negative 1.5. Now, guys, if we wanted to graph that, we would have had to make it equal to 0. So this would have been a little bit crazy. we would have said 24x squared minus 54, because that's how we would have gotten it equal to 0. If we had done that, it would have been a very, very, very skinny parabola here, but it does look like my solutions are negative 1.5 and positive 1.5. Negative 3/2 and positive 1/2. Do y'all feel good about that? Awesome. So guys, solving by the square root method is really, really great when you are trying to, when you don't have access to be able to find your solutions with technology and stuff, all right? So now we have 5x squared minus, 5 times x squared minus 9 plus 5 equals 5. All right, so does this have a bx term? No, it does not. So we can do this a few different ways, guys. If we want to isolate our x squared, we can distribute and simplify and all that stuff. I would go ahead and let's see here. Let's distribute. So that's going to be 5 times x squared is 5x squared. 5 times negative 9 is negative 45. Plus 5 is equal to 5. So now I get to combine these terms together, don't I? So that becomes 5x squared minus 40 equals 5. And then I add 45 to both, add 40, my bad. I was jumping ahead there. So I add 40 to both sides. So that becomes 5x squared equals 45. Okay, I'm still not there yet. This one is taking a little bit of while. So 5x squared equals 45. Now I need to divide both sides by 5. And we have x squared equals 9. Finally. So now that x squared equals 9, what am I going to do with both sides here? Take our square root, and we have x is equal to plus or minus 3. Are y'all comfortable with that? Yes? Awesome. All right. Now, number 7. Now, guys, we don't have an x squared term, do we? Like we did on 1, 3, and 5. Now we have a squared binomial. So, guys, what we want to do is we want to isolate this squared binomial. So we are going to treat this guy like it's one little thing. We're going to keep it all together. So the first thing I want to do is I want to add 43 to both sides. Are y'all okay with that? And that is going to leave us with x plus 3 squared is equal to 21 plus 43, that is 64. Okay, now that we have x plus 3 squared equals 64, we want to do, so then, guys, now we want to take the square root of both sides. Because if I take the square root of x plus 3 squared, all I'm going to be left with is x plus 3. Isn't that awesome? Mm-hmm. But if I take the square root of whatever you do to one side, you got to do both sides. So, guys, what's the square root of 64? Plus or minus 8. Right? It could be positive or negative 8. So, y'all, really what we're doing here, now if we have to solve for x. But we have to solve for x with both positive 8 and negative 8. Does that make sense, guys? So if I subtract my 3 here, gets a little confusing. If I subtract my 3 here, what I'm really doing is I'm saying x is equal to 8 minus 3, and x is equal to negative 8 minus 3, right? I have 2 of them. Does that make sense, guys? Are you guys tracking me? Okay. So then, what's 8 minus 3, y'all? X is equal to 5. And then, negative 8 minus 3, my x is equal to negative 11. So my 2 solutions are 5 and negative 11. Do y'all feel okay with that? So, really, guys, solving it by square root is not too bad. Now, if you have access to the technology, it is nice and helpful. And so I'm going to show you all this really quick. Sorry. Got a little ahead of myself here. So if we go back to the equation, it was x plus 3 squared minus 43. So if we wanted to graph it, we would need to subtract 21. So that would be, let us see here, x plus 3 squared minus 64, right, if we wanted to graph it. And guys, if you graphed it, look right there. What are my zeros? Negative 11 and positive 5. Do y'all see that? So it's right there at negative 11 and positive 5 are my zeros. Or if we don't have access to lovely technology like that, we can also just graph it using good old-fashioned algebra and get 5 and negative 11. All right, guys, so now what I want y'all to do is I just did all the odd numbers for you, so I want you guys to do the even numbers, all right? So I'm going to leave these guys up here so you guys can kind of see these, but I want y'all to work on the even numbers, and I'm going to walk around and see how we're doing. All right, y'all, so these are the correct answers for numbers 2 and 4. We added 14 to both sides, then divided by negative 2. So we had x squared equals 81. You take the square root of that, and we have x is equal to positive 9 or negative 9. Now, guys, our plus or minus 9 is kind of the terminology we use there. Okay? And then for number 4, I went ahead and I distributed my 2 there to get 2x squared plus 4 minus 6 equals 6. I combined my 4 and my negative 6 to get negative 2. I added 2 to both sides, and we had 2x squared equals 8. We divided both sides by 2. We had x squared equals 4. Take the square root, and we had x equals plus or minus 2. Do y'all feel good about that? Mm-hmm. Awesome. Okay, for number 6, I'm going to show y'all this one. This one's not too bad. All right? So we take the square root of x minus 2 squared and 49, and we got x minus 2 is plus or minus 7. Now, guys, one thing I do like to do is sometimes I like to write it out as 2 separate equations so that I don't screw up that plus or minus thing. Do you guys know what I'm talking about? So that becomes x minus 2 equals 7, and x minus 2 equals negative 7. So we had x, and then we added 2 to both sides. We had x equals 9 and x equals negative 5. How'd y'all feel about that? Pretty good? Okay. Okay. So now, for number 8, I want to actually do this one with you guys. All right? So for number 8, the biggest mistake I see with folks on number 8 is they try to distribute this 5 and make that 5x minus 35. Can we do that, though? Because of that squared. So we have to treat this x minus 7 kind of like it's its own term. So the first thing we're actually going to do is subtract 27. All right, y'all? So that becomes 5 times x minus 7 squared is equal to 32 minus 27 is 5. Now, we want to get the squared binomial by itself, so we are going to divide both sides by 5. Are y'all comfortable with that? Yes. Awesome. So that cancels that guy out, and we are left with x minus 7 squared equals 1. All right? So then, if I take the square root of both sides, well, guys, what is the square root of 1? That's a beautiful thing. It's just plus or minus 1. So we have, I'm going to write this guy over here, x minus 7 is equal to plus or minus 1. Are you guys okay with that? So now, we can either write it as 2 separate equations, or we can write it as one little equation here. I'm going to add 7 to both sides here. So, the way we can think about this, guys, is this is going to be x is equal to 7 plus 1, or x is equal to 7 minus 1. Are you guys kind of tracking me on that?
Yep.
We had 7 plus 1 and 7 minus 1, so that's going to give me 8 and 6. Are you guys good with that? So our two answers here were 8 and 6. All right, y'all, so this is how we factor this is how we solve a quadratic if we have those lovely, perfect, if we solve using our square roots. All right, guys, y'all feeling good about this today?
Mm-hmm.
Awesome, okay. So next we get to talk about completing the square.
That sounds so fun.
It is super fun.
That was sarcasm.
So big, it's just going to be a lot of work.